Hey, morning guys. Welcome to Physics 145. We're going to start with Chapter 1. So under Chapter 1, there will be a few subtopics that you have. Here will be units. Number 1 is units. Number 2 is physical quantities. And then under physical quantities, we have base quantity and also derived quantities. And then next one is prefixes. Okay, and then finally is conversion of units. Now look at, first we start with physical quantity. So what are physical quantities? Physical quantities are something that you can measure, the quantity that you can measure. So, can be measured, okay? You can measure, everyone else can measure. If you are supposed to measure the same object, their size is supposed to be the same. So that means can be repeated by other people. Okay, can be measured, can be repeated by other people. And then normally we can attach a unit to it just to tell people how big is the size. Alright, so these are the meaning of physical quantities. So example of physical quantity. Okay, example of physical quantity, there will be a lot. Something like speed, number 2, length, or height. If you stand up, the how tall are you is called height. But if you are dead on the floor, I can measure you. I call how length is this, Mr. Ho. Alright, for example. Now, other than that, can give you one more. Time. Time is something that is called physical quantity, even though we just have a feeling of thing passes. Time passes, so that is something that you can measure. Well, of course, people cannot measure what you have measured before if you don't do things measured together. Alright, for example, yesterday I measured something, an event. Okay, only I personally see it. Maybe I look at the shooting star. So you tell people, can people measure that thing because it's already over? Unless they are so coincident that there are two persons measure the same thing at the same time. Alright, so time will be a bit special. So this is physical quantity. Now the next one is, what are other quantities that is not physical quantity? We call it non-physical. Okay, non-physical quantity, of course, it is not to say cannot be measured. Okay, cannot be measured easily, not that easy to measure. Right? We talk about that one later. Of course, it's the same thing. As long as there are some quantity, it can be repeated by someone else, but again, not that easy. Okay, not that easy. Example, okay, of physical quantity. For example, emotion. Okay, emotion. Okay, emotion. Well, under emotion, since we are human, there will be a lot of category under emotion, like anger, okay, love, what else? Greed, how greedy you are, and then anything else? Hatred, how much hate you have on a certain person, and what else? Funny or happy? Funny. These are things that we can understand whether a person is angry or not, they're happy or not, they fall in love or not, by looking at so many features around that person. But if you want to put it into a measurement, it's not that easy. That's why we have people that do the job like this. For example, psychologists, psychiatrists. Okay, if you go to psychiatrists, maybe they have some of this problem. Maybe another one is craziness, how crazy you are. Well, if you go and see psychologists, maybe there is a very serious problem. And then maybe like psychopath. Okay, psychopaths, these are all under non-physical quantities. Okay, so some are just very common, some are very crazy. Maybe like something, okay, something spiritual. Okay, something spiritual. Well, at the moment, our something spiritual might not be something that we can measure, accepted in science, but sooner or later, I believe all these things will be put it down in your syllabus, maybe your anak cucu and so on. They will learn something spiritual. They might have equation for calculating spiritual goals, for example. Okay, something that live in between present life and death. Okay, in between there. So if you talk about one physical quantity are something that we can only measure, can only be seen, that is not entirely true. How about time? Can you see time? No, we see the process happen. So we assume that something actually passed together with it. That is time. Alright? So these are examples of non-physical quantity. Alright? So the next part is, how do you tell people, now we go back to physical quantity. How do you tell people that how big is a quantity? By comparatively. Okay? By comparison. So we need to put something so that people know. So that means in physical quantity, how to tell people the size of a physical quantity. Okay, how to tell people the size of a physical quantity. So you need two things. Number one is number, because number is universal. You cannot say, oh, that is big. How big is your big? It can be big like a eraser. It can be big like something like this, or it can be big like a whole whiteboard. So it must be very something that is a number that you tell people. People when look at the number, they know the size. Okay, so a quantity, physical quantity, must have numbers. Okay, numbers. And then followed by another thing that we call units. Okay, a unit. So you have number without units, unless you're talking in the same group. People know what you're talking about. People know what unit you're talking about, or else that unit, that number will be meaningless. Okay. So for example, maybe you're talking in a pharmaceutical company. Maybe they talk about milligram. So maybe they talk about 250. When they tell you, you take 250. Panadol, they mean 250 milligram Panadol. For physics, we normally talk about mass will be in kilogram. You are not going to take Panadol 250 kilogram, right? Might as well go to church and see some father and brainwash yourself first, right? So there is not something that is right. So unit is important to let people know that the size that represent that number. So that is for the way we represent a physical quantity. So your physical quantity have two parts, numbers or the magnitude and the unit you use. Okay, so we are using mostly SI unit because there are still some other countries use a unit that is not SI. For example, certain unit like foot, inches, pound and so on. So these are unit that is imperial, not SI unit. SI unit means a country that involved in those research and so on. The whole country use the same unit as you. So when you go there, you talk about measurement, they will understand what you're talking about. So those are the purpose of SI unit. So for example, my height, normally we use h is equal to 175 centimeter. You see? So this is 175, the number, and this is a unit. All this one is actually the same as 1.75 meter. So you are familiar with all these things. You have to familiar with this, okay? And then my weight, my mass is only 35. No, I'm just joking. I'm actually, that is my 18 years old mass. So my mass now is, well, a little bit over 92 point something, but I prefer it to be 92 lah, because it looks smaller than 92.9, right? So now, if you change to weight, your weight will be m times g, and then this is g is 10, so your 92 times 10, 920 Newton. So you see all these things, they come with a number and a unit. So when you talk about things like this, people will know what you're talking about. So for example, if you go to UK, you say, people ask you, what is your mass? Okay? Or what is your mass? You say 92 pounds, 92. They will assume you say 92 pounds. 92 pounds is maybe half of my body mass. So that is the problem if you don't talk the same language. Alright, so these are how you tell people the size of a physical quantities. Alright, so that is basic for physical quantity. Now we look at the next one is under all this quantity, physical quantity, we emphasize on physical quantity. We have two types of physical quantity. One is the base, okay, the foundation that we call the base quantity, and then the second type will be the derived quantity. We derive it, we get it from all these base quantity. Alright, so we look at now the next one. We call it the base quantity. Okay, base quantity. They are all together 7 base quantity. Okay, but I think mathematics they have additional one, which is 8 altogether. So we look at the base quantity and their symbol and their units. Right. So these are the base quantity. The name of the base quantity will be here. Name of base quantity. Okay. And then this is a symbol used, and then there is a unit, and this is a symbol of the unit. So this is the symbol for base quantity, this is the unit used, and this is the symbol for units. Okay, our first one is the mass. Okay, the mass symbol is M. Okay, and then the unit will be kilogram, and the symbol for units will be kg. The next one is length. Symbol is L. You follow the first letter of the word, and then the units for measuring length is meter, and the symbol is M. Okay, and then the next one is time, small t, and that one in second, and the symbol is S. Okay, and because of the standard, the time is one of the most standard ones. Since long time ago until now, they seldom change the unit. And then the next one will be electric current, or temperature. Sorry, temperature first. Okay, our temperature will refer to thermodynamic temperature, and the symbol is T. Sometimes we use theta, and then the unit will be Kelvin. Okay, and the symbol will be big capital letter Kelvin. There is no degree. You don't have that symbol, only Kelvin. Alright? You have that dot symbol only for Fahrenheit and also Celsius. And then the next one is electric current. Okay, electric current. Symbol is I, big capital letter, and the unit will be ampere. Okay, and big capital letter A. Right, so these are the first 5, the foundation, but we have another 3 here. So the next one is amount of substance. Amount of substance means how much thing you have. Okay, how much thing you have. This one is normally related to chemistry, but physics we also use it. Now the symbol for amount of substance will be N. Okay, N. And then n, small n, okay, small n, and then the unit will be mole. Okay, mole, not the mole on your face, but this is M-O-L-E, and then the symbol for the units will be M or L. You are very familiar with this. So this is more or less like when in chemistry they ask you to find the number of mole of a certain chemical. And then the next one is luminous intensity. Luminous intensity tells us the brightness of a certain light source. For example, the luminosity of the lamp and so on, luminosity of the sun and so on. So luminosity, the symbol we use is most of the time is IL, luminous intensity. Okay, and then the unit is candela. Okay, candela. And then the symbol for candela is CD. Okay, CD. Now, this candela unit is an old unit, so the new unit now we use is normally lux. Okay, lux, and the symbol is LX. Okay, lux. But believe me, in your whole life, maybe you use this one or two times only. First time in STPM, second time in your diploma, only for exam purposes, right? So I'm teaching physics for about 30 plus years, and until now I never used a unit in my life before, alright? Just to let you know, okay? Maybe tomorrow I use it, okay? Last one is solid angle. Okay, solid angle. Well, solid angle is mostly we use a symbol of theta. Okay, solid angle, and then the unit will be radian. Radian is a unit you know in radian. Okay, and then radian is solid angle. So solid angle, the radian is STR. Okay, radian. So these are the example of these are all the base quantities that you must know, but the important one is up to here. Okay, up to here, 1 2 3 4 5 6 of them you must know, okay, because these are the basic. For example, the mass, length, time will be the basic for your mechanics, and then the temperature is for your thermodynamics, and then the electric current will be for electric field, and so on. Alright, now that is our base quantity, but we still want to look at what is actually the meaning of base quantity. Give you an example. So the meaning of base quantity is what? Okay, meaning of base quantity. If you look at this, mass, length, time, temperature, amount of substance, except this one, okay? Because we know that something is not right here. If you look at the actual basic one, ampere actually is built up from something else, so we ignore this one first. If you look at the rest, there's no way you can talk about those things in any other thing that is more basic than them. Okay, for example, mass. What is mass? Mass is something that the amount of matter in a certain object, the total amount of matter. There's nothing that can actually combine to form mass other than the actual matter itself. And then time is something that is so pure that you cannot actually talk about time in something else. Time is time. You tell people time passes, okay, they won't say that our time is made up of this and that and so on. Okay, so that is base quantity, right? And then you talk about length. Length, of course, depends on how you put things to measure. If it is like this height, if it is like that, that is normally length. All right. So meaning of the base quantity is, okay, the quantity, the physical quantity that are not made up of any other quantities. It was not made up of any other quantities. Okay? Not made up of any other quantities. They are standalone. They are independent. Okay? They are independent. Okay? They are independent. That's the most important. They are independent. They are not depending on anything else. Okay? So that is the meaning of base quantity. Now, base quantity also come with their own units. So we call this one the base unit. Okay? The unit here is called the base units as well. And the symbol, standard symbol that you must remember. Alright? So these are the base quantity and the meaning of the base quantity. Alright? So the next one will be, after base quantity, we cannot just simply describe our whole world phenomena based on all these 7 quantities only. They are actually not enough. Okay? Not enough. So scientists normally create or found or discover new quantity other than this base quantity. So though discover quantity other than this one, we call them derived quantity. Okay, we call them derived quantity. Okay, so the next one is our derived quantity. Okay, So now, since we already know roughly the base quantity, now we want to derive what is not derive. We want to talk about the meaning of derived quantity. Derived quantities are quantities here, IES. Okay, derived quantity are quantities that were created. Okay, that were created by combining, two or more base quantities, based on the following procedure. Procedure. Number one, from experiment. From experiments. Sometimes experiment, you do this, measure this, and calculate it, and finally you discover something new. From experiment. Number two, from equation. From equation. Normally from equation, this is more theoretical. They are more theoretical. Alright, so physicists will have theoretical physicists, we have experimentalists and so on. People that like theory more, people that like experiment more. Just like the job for astronomer, the difference between astronomer and astronaut is what? Astronomer, they can talk, they can tell you the story of a star, they can tell you the story of planet and other galaxy just using their theory and telescope. But astronauts, well, they like astronomy, but they want to reach there. That type of experience is more important to them, right? Doesn't mean they are not good in a theory. Sometimes they are professor, but they want to have a hands-on experience. You talk about, well, a stone on surface of Mars. By taking photo, you study them, but they are not really real. But these astronauts, they want to go there and touch the stone, hug the stone, hit the stone, smell, and whatever they want to do. So this is the two important thing where you get. And then example of our derived quantity will be a lot. Every chapter in your Physics 155 will have their own respective derived quantity. So give you the first one is speed. Speed is what? Speed is equal to distance divided by time. So your distance is the same as length, because speed we don't talk about direction. So distance is one quantity, another one quantity, so there are two base quantities. So you see, we have two or more. So two, you combine, you get something called derived quantity. And the unit will be the unit of the distance divided by time, meter per second. And then the next one will be something like, for example, acceleration. Acceleration is speed divided by time. Speed divided by time, it gives you meter per second per second. Alright, so that is acceleration. And then number three, something a bit different here. Let's say force. So what is force actually? Force is equal to mass multiplied by acceleration. So we have mass multiplied by acceleration. So the unit for force will be now kilogram meter per second per second. But we seldom use that unit because it's sort of like very long to pronounce it, so we call it Newton. Newton. Then last one, we have pressure. Pressure is equal to normal force divided by area. So now we have another new derived quantity. Force, which is made out of mass and acceleration. Acceleration made out of speed over time, so there are so many base quantity involved here. So this force has the unit of Newton per meter square. Normally you use this one under pressure, alright, hydraulic system and so on. So there are thousands of examples. So you need to know all of them. Every chapter, their unit will be in your exam. Alright. So this is our the first part of our base quantity and derived quantity. Our next video will be on your units, prefixes, and conversion of unit. Okay, wait for the second video. Thank you.